Hi there. Today I would like to create something cool again with Three.js, a project that has to do with particles. So this will be a Three.js Particles tutorial. With particles, we are going to create a star effect. You know, the stars are going to be created with particles, so things like stars or rain effect, snowing, etc. uh, Usually you use particles to do these things in a 3D world environment. As you can see, this will be the project that we are going to create in this video. This is the planet Saturn, which I have, I really like this planet and its rings. And you see the stars, they have some animation, they move slowly. It's the speed and the, the effect I wanted to give them. And yeah, they have some animation and textures. Uh, Also, we will import this model in our website, and we will learn many things about particles in this video. So if you want to join me, uh, we can start. I want to say that this idea of doing this tutorial came to me after seeing the launch of NASA's Artemis 1. I think that everybody has seen the launch of Artemis 1, taking the next big step in returning humanity back to the moon. It's interesting to see that the Artemis tracker in this website, it's their website, their online orbit website in real time, is made with Unity engine. And for me, that I'm a big fan of Unity, I'm very happy to see this. You see it, the logo of Unity, and yeah, we can take a look. You see, looks like a Three.js project actually. If you have seen my previous video with when we created the Earth, it's like something like this. It's something like this. Also, the stars that we are going to create, yeah, will be something similar. And also the 3D part, we also will add controls, to control the scene. Yeah, this was when I was watching this launch. It came to me the idea to make a tutorial about something similar. Yeah, why not to create a sky full of stars with particles, add the 3D model there. Since we created the planet Earth in the previous video, if you didn't watch it, I invite you to take a look. We create their planet Earth, we export it to our Three.js or React project website. And so this time we will use the planet Saturn, and but we will focus on particles on this tutorial. Okay, again we will do it from scratch, so we will start from zero. We will create the files, the project, HTML, then the Three.js scene, camera, renderer, and everything, canvas. Then add the lights, then add the modules, then create the particles, the vertices. We will manipulate vertices. We will learn how to do that, and so on. So yeah, let's start with this project. Let's close this. So yeah, this was the launch of Artemis. If you
And
didn't
here we
see it,
go.
10.
Hydrogen burn-off igniters initiated. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128
This
miles
was
per
very
hour.
inspiring to see. But let's create our small project about it. Okay? So, as usual, window plus R, write CMD in the run window. And here CD desktop, let's go to our desktop. We want to create the project here. So for this mk dir, let's call the project Saturn. We created the folder for our project. Let's go into this folder, cd Saturn. Now that we are inside this folder, let's open it with Visual Studio, the editor that we are going to use. That it's the editor that I recommend. It's the best out there. This is for sure. You can use the editor of your choice, but yeah, VS Code is the best. So to open VS Code in this folder, code and dot. And here we are. Let's close the terminal. Now, in the last tutorials about on 3D gallery, art gallery, I used the Three.js scene and the project without a server. We opened the local server with HTML going live. In this tutorial, I will add the server too with Webpack, but it needs a separate tutorial to talk about the server side. To create one, Webpack is a bit not complex, but there are some things to explain that maybe in this video it's not the purpose. So you can find in the description in my GitHub repository. You can copy this folder, you can clone the repository, and I will tell you how to start the server. So we will have a server, okay, to run our Three.js project. With the server, we also will have the node environment, so we can use npm, and with npm we can install packages. These packages are like external dependencies, external libraries that we might need in a moment at our project, in this or in other projects that you will create yourself. So it's good to see how to do it, and I think many of you would want, a server for your projects. So why not? You have the server ready. You just need to copy those folders or clone the repository. So I'm going to add those folders. I have it here. Yeah, Webpack. Let me find first. Okay, this is the new project that I'm working right now. Let me add this bundler with Webpack. Okay, so paste it here. Now we have this Webpack bundler and another folder static for checksters that we will need for the 3D model, the Saturn planet, and also some checkster about the stars that we will create. Yeah, So to run this, before running this, I need to create a new folder src, the usual folder src that we use in every project, not only with Three.js but with React and everything. And inside src, we would need, of course, an index.html file. Then, of course, a CSS file, even though these are not important in this tutorial. But yeah, just the basic style and the basic HTML template. We also need the script file for JS and our Three.js. Okay, here we are. Now, we can simply start by first creating the simple HTML. Okay. Meanwhile, I will add the basic styles. Let's run the server. Because to run the server, after you created this, this launcher with webpack, etc., you need, when you clone or when you add these folders from another project, you need to install the node modules. To install the node modules, first open the terminal, ctrl O with the accent, but it depends on your computer. So npm I, simple as that. The command npm I will install the node modules, and the node modules that are inside this package JSON. Usually when you clone a repository or when you previously have worked with this project, you have here in the package JSON, in the dependencies section, you have all the libraries and that you will install with npm. And we see here Babel, that is to webpack, some other dependencies. We also have here three and some other libraries that we will need. So to install all these dependencies, just type the command here, npm I or npm install, the same thing. It will take a while depending on how fast your computer is, but yeah. Meanwhile, I added the HTML. I can add the styles. So Saturn and particles. Okay. For the styles, I will not add, just some basic stars style. Okay. This symbol is for everything. I don't want any margin or padding. So margin 0. Got this Copilot always want to. I don't need you now, even though you are helpful. Okay, node modules slows down my computer. Maybe your computer is faster. I wait just a little bit. Okay, imagine that. It takes a while to Yeah, it really slows down my computer. I don't have the best computer, yeah. You might wonder why, since I do 3D stuff, but yeah, this is my laptop. It's not my desktop. I have it in another room, the good one. So this is, the laptop that I take outside or when I move in my house, whatever. So overflow is hidden. Overflow is just to hidden the scroll bar. We don't want that in a Three.js. Also, some style for the canvas. I don't have the canvas here. Always, you need to add the canvas in a Three.js scene. Uh, in my previous tutorials, I used another method for the canvas. I just created the render and the render will generate the canvas. In this tutorial, I will do things somehow different, just so you can see the different methods that you can use. So I will add an element, Canva, and we'll give it a class of canvas. For that, you have a shortcut, very quick. So canvas dot, the name of the class that I want to give, canvas. So canvas dot canvas, enter. It will create the element with the class. So instead of writing canvas, then class, then So here, canvas, position fixed, position fixed on top, 0 on left, 0, and outline none. Okay, just the very basic styles. We don't need much because we will create a 3D scene, so we don't need the CSS. We have the HTML, we have the CSS. Now let's go to our script, and here it will start our project. The first thing to do, apart from just importing that style, import the style.css. Okay, style.css. Okay. The first thing always when we will create a Three.js project is to import this three source code, this three module. It depends to call it module because in this project it will be a module we will import via npm. We will import it like the other modules. And I think we already imported here since it finished. In node modules, if we go and search, you see Bubble, Webpack, etc. It's pretty huge. We will find also three. Yeah, it's somewhere here. Three. Okay, it's here. You see, we will import this one to our scene. This is the whole free source code, that will make us able to create everything, all the 3D objects, geometries, materials, etc., etc. So let's close this. Here, to import this, after, of course, you installed it, usually when you don't have these node modules from another project and you do npm I, you need to install it yourself. For that, you can go and search in Google 3 npm or 3 module, and usually it's npm I3. npm I, the name of the, the library of that you need. Okay, now we need to import it in our scene after installed. Import asterisk as 3 from this path here, not modules. Why asterisk as 3? You import everything as 3, like everything with this name. So this will be the main, the main object that has everything inside, as all the classes of Three.js. So import everything with this name, 3. You call it 3. You can call it whatever. You can call it chicken. You can call it whatever, car. But, of course, 3. And the path here it's long. It's 3 here. So you don't write not modules, but 3 it was here. Yes. In our node modules 3, then after 3, it's for other things that you may need, you will write, a longer path, not in 3. But here, since we need the whole thing in 3, we just need only 3. Okay? So import asterisk as 3 from 3. We imported the 3. Later we will need something like orbit controls, the GLTF loader that is to make us possible to import the 3D model from outside, our 3D model. And they are inside this 3. We will add a longer path. We can do it now since we are here. We will add it later, but yeah, we can import it at least. The first is orbit controls. Okay, orbit controls from, and here 3. It's always inside this node modules. 3. Then examples. Okay, it's this suggestion there. JSM. Again, we have the suggestions here. JSM, then controls. And after controls, we have orbit controls here. Okay. These are some classes that are out, for example, if we download the 3 from GitHub, as I did in my previous tutorial on 3D Gallery, we didn't import it like this with npm. We imported the whole thing as a file. So in that case, it is not there. You need to download it on GitHub. On this, also in GitHub is like this path. 3 examples, JSM, controls, orbit controls. Don't get confused about these details. Just follow this and you will understand it when it will be the moment that you need these things. GLTF loader. Okay. The same thing for this is 3 examples again. JSM. Here is animation, cameras, loaders. Okay, no, don't trace others, it's JSM. Where is loaders? Okay, it didn't show there. Okay. Then GLTF loader. Okay. We also have. We imported what we need. Don't worry if you don't know what is the purpose of this orbit controls and GLTF loader. We are going to use them and you will see yourself. For Three.js scene, we need some basic scene and the most important things that we will always use to create the scene. And those are canvas, the scene, camera, lights, renderer, and animate to animate the when we render everything. Okay, let's start from the canvas. So const canvas, no, not uppercase, it's a variable. Const canvas, let's give this variable the HTML element of canvas here that has the class canvas. So for that, it's JavaScript, has nothing to do with Three.js. So document dot query selector and the class that has the name of canvas. So this is JavaScript. DOM manipulation. So this variable canvas has this reference here. For the scene, it's simple, const scene. This is our variable for the scene. And to create the scene is new 3.scene. That's it. We created the scene. When we write new, it calls the constructor of the class scene. From object-oriented programming, if you know about it, I'm always referring to beginners here, guys. So sorry if I'm boring or repetitive, to mention some basic concepts, but maybe not everyone has, the knowledge of object-oriented, or they are beginners, they want to learn. So I will mention very briefly about these concepts. So when we write new, we create a new scene. The word itself is explanatory, new. But behind the scene, new calls the constructor of this class scene. 3 is the main object. This main object 3 contains inside all the classes of Three.js. One of these classes is scene, for the scene. And this class, like every class, has a constructor with, constructor has some properties inside that are like, for example, in this case, like this color or this name, this, that refers to this object that you instantiate. And you instantiate every time you call this new. Every time you call this new, you instantiate a new instance of this scene class that has that constructor. Okay? I hope it's clear, but if not, you can always check, the concepts about object-oriented, about classes and constructors and etc. it's JavaScript or any other object-oriented language. So just think about it. New something. New scene, new camera, new light, new whatever. If you don't want to understand what happens behind this behind the scene. Okay, so we have the scene. Let's create a camera. The same thing. We create a variable const because it's a constant. We are not going to change this camera. You can use const or let, but since it's a constant, we use const camera equal, again, new, as we said, new, we are calling the constructor of this other class. Then this other class is again from three main object, and it's called perspective camera. I talk about maybe some more details about the cameras in my tutorial on 3D art gallery. So if you want, you can check. But this is a simple camera, perspective camera. Or you can always check the documentation and search on Google to understand more on cameras. Perspective camera, orthographic camera, etc., etc. So perspective camera. This perspective camera, you see here, accepts some parameters. This is FOV, that means the field of view, and it's a number. Aspect, that it's the aspect ratio, near and far, that is, the angle for near and far. Again, there is a lot to explain here about cameras. So I explain a bit in the other tutorial, 3D art gallery. So I'm not going to stop on this, but yeah, it's the near and the far. And the first parameter, we start from the field of view. Okay? For the field of view, there is a good range from 30 to 80, not more than 100, but yeah, usually I use 75. It's a good number. Let's add a comment here. FOV, field of view. This is the first parameter. The second parameter, as we see here, it's the aspect ratio. The aspect ratio is width divided by height. Width of what? We want the width divided by height of the whole scene or our window. And for that we have the window object, of the browser. So we use window dot for the width, it's inner width. So window dot inner width divided by window inner height. So we have this aspect ratio. Window dot inner height. Okay. Comment aspect ratio. This is the first and the second parameter. The third is for the near angle. So we just needed, 0.1 for the near. It's the normal that we use. And for the far, you can use a number between 100 or, if you don't want to miss something, use 1000. Again, you should check the documentation to learn more in detail, since yeah, maybe they deserve a tutorial apart. We can explain it in this video too, but it will take then too long, or you may be lost from the main purpose, that is particles. I spoke more in detail about this in the other tutorial, so check it out. 3D art gallery. Near and far. Okay. Oh, I made a mistake here. I was not looking at the scene. We are in the scene here. We need this inside the camera. Sorry. Yeah, I didn't see. I was talking and I didn't see nothing. Okay. So inside the camera, guys. The scene is like that. You just need 3 scene and you are okay with that. Here are in the camera. Something else. You created the camera here, but you will not see anything in the browser, because for the camera to be able to look at the camera, you need, by default it's on 0, so you need to pull it back a little. So if you have the camera like very near your object, or you are very near, you cannot see it because it's in the same position. So you need to pull a bit back the camera, so you will be able to see the scene. So for that, you need to change the position of the camera in the Z axis, because the Z is, forward or backward, or the depth, since we are in a 3D scene. So camera dot position dot Z, you access the Z axis, and to change that, just put a number like 3 or 1, 2, 3, but let's use 3 just to pull it a little. So this is pull. I will add the comments, so in case it will help you maybe later. Pull the camera back a bit if you cannot see. Okay. Again, you will not see anything in the scene, because to see, you need to add this camera to the scene. Every object needs to be added to the scene. And to add something to the scene, we use scene, that is the variable that we created above, dot add, the method add, and inside we pass the parameter that we want to add, so camera. Okay, so scene is the variable here that we created, dot add, the method to add something to the scene, we pass the parameter camera, and that's it. Now we added the camera, and we are here to add the lights. To add the lights, initially we can add the simple light, that's the ambient light, and the ambient light lights the whole scene equally, so everything in the scene, and lights everything equally. Okay, to be able to see things, we need these lights, because if I add now the 3D model, the planet Saturn, I won't see it because there is no light. It will be in the scene, but I will not see it. So again, create a variable, const, let's call it ambient light. It's always a good practice to use the name very significant, to add the description to the name, so ambient light, point light, etc., etc. And always in camel case for the beginners, these guys. So if you already know these very basic things, just bear with me. Again, new instance, we call the constructor of the class ambient light. So new 3 dot ambient light class, and we pass as parameters the color and the intensity of the light. For the color, it's just a white color and this F. 1, 2, 3, 4, 5, 6. Okay, and the intensity of 2. Okay. You can add a position always to the light too, you know. You can add the position to it. For example, ambient light. I will not add any position. I will leave it in the center of the scene. You can use like specific axis like position.x, position.y, position.z, or to set all the 3 axes, you use the method set. So position.set, and then pass all the 3 parameters for x, y, and z. So 0, 0, 0. Okay, or you can do position.x, then again ambient light position.y, then again ambient light position. Etc. etc. Again, the light will not be in the scene even though we create it, because, as I said, every object that we instantiate and we create here, we need to add it to the scene. And for that, we call the variable scene.add method, and we pass this new created variable ambient light. Ambient light. Now the light is added to the scene. I'm not going to open the browser yet because I am creating, you know, the basic scene. And then we will run npm run dev, you know, that will run the webpack server. Okay, so we have the light, the camera, and maybe add another light like point light, just, you know, const point light. Again, new instance, 3 main object, and the class of point light. And again, we pass 2 parameters, a color, 1, 2, 3, 4, 5, 6, and the intensity, 2. You can move the point light, again, as you prefer, if you need it in the scene. Like point light, that position. I'm repeating this just, you know, to make you stick. I advise you to do it the same, just to practice, and it will become a second nature. Position, that set, and 3 parameters, x, y, z. In the end, add it to the scene. Scene dot add. I think you got used to it already. Point light. Okay. And the lights are ready. I have okay, you see here something interesting. I made a mistake. It's not really a mistake. It's okay, but I didn't see again because I instantiated here new perspective camera without the 3 main object. But I used the shortcut here to import it like this. It's like basically the same thing. This is like you import single classes from 3 main object. Or here you import everything and then use this 3 dot camera 3 dot etc etc, or import single things. But I don't want it like this. I am using 3, so new 3 dot perspective camera. Okay. And then one of the most important things is the render, to render things in the scene. The render is like the screenshot. You have the camera and you take a screenshot. Okay, so for that you need the renderer. For the renderer, again, the same thing. You create a variable and you call the constructor of that class that you want to use. And in this case, for the renderer is WebGL renderer. This is the name of the class. So const, the name of the variable renderer, equal new colon the constructor of the class 3 dot, and the name is not like renderer as you might think, is WebGL renderer. So WebGL1, no, not this one, WebGL renderer. GL is uppercase, WebGL render. Okay, this one, because there is one WebGL1. Oh no, not least, WebGL renderer. Come on. Okay, why so difficult? And we pass inside an object. If we didn't use the canvas element here, the renderer will generate the canvas itself, as I did in the other tutorial on 3D art gallery. Here we have this canvas. I wanted to use different methods in different tutorials. So yeah, we point to that element. Okay, so canvas property, canvas element. Okay, so canvas is the canvas element from the HTML. Okay, HTML, and this is done. But we need some other, let's say, to add some other manipulation to the render. For example, to set its size, to save the aspect ratio, pixel ratio, etc. But to create the render, you simply write this new 3 WebGL render and pass inside the canvas element. Then for the size, render dot set size method. Again, as we used with camera, for the aspect ratio, we use window.inner width and window.inner height. So two parameters here, window.inner width and window.inner height. Dot inner height. Okay, and that's it. Also, I want to add render that set pixel ratio. Okay, and here I want to add math. That means I will explain it. Math, that means window dot, again window dot device pixel ratio and another parameter of 2. So this is to avoid pixelation on high resolution screens. For example, if someone of you is using a very big screen, this is to avoid the pixelation on high resolution screens. Okay, this is why I added to avoid pixelation on high screen. Okay, and that's it for the render. Now with this render we need to to take the screenshots, we need to take the camera and the render. So to make possible, as we said, to take the screenshots. Okay, so to use the render, we access it like this on this animate function, because I will create an animate function that will pass there if we have animations or that we will use later, and also on every frame we want to render the scene, so on every frame we will render the scene. We will create a function here called animate with ES6 syntax for this parenthesis, and okay, we have a function here. Inside here we call render dot render, okay, and we pass the scene and the camera. As you can see here, the scene and the camera. Scene, camera. Okay, that's it. Also, what we need here in this function animate is to add the window request animation frame. I talk about it in the other tutorial. If you want, you can take a look on Google. Request animation frame. Yeah, it's on JavaScript MDM. Method tells the browser that you wish to perform an animation and requests that the browser calls a specified function to update an animation before the next repaint. So basically, this is to call this function recursively on the next frame. So on every frame, you call in a recursive way this function itself. Okay, so on next frame, it will call this function. On next frame, it will call this function like this. Window dot request animation frame, and we pass here the function recursively. Okay, if you don't know about recursive etc., you can do your research, but basically it's like it calls itself, this function. On the next frame it will call animate. Calling animate, it will start again, it will render scene and camera, and here it will call again animate again. So this is like a loop to be able, when we have animation, for example, I want to change a bit the speed, the velocity, the position of something, or rotate something, for animation, or to take a render at every frame, use this window request animation frame. And this is because a solution, because every computer has different frame rate per seconds. So on one computer it will be slower, on one computer it will be faster. So this is to a solution to this. So it will update the things on the next frame. Okay. You can read more in depth the documentation. I always suggest you to read more documentation to maybe to understand things more in detail. But that is for now. Okay, so we have basically everything. Oh, we need to call this function in the end, of course. Okay. We have everything that we need for a basic scene. We don't have anything to show, but yeah, this is, that the most important thing that we need in a Three.js scene on every Three.js project. So to run the server and to open this project live, we run npm run dev. It will use the server and it will open this project live. Yeah, sometimes it takes some seconds. Okay. It will open on this address or localhost 8080. If it doesn't work with localhost, add this address here. You have two choices, localhost 8080 or this address. Maybe sometimes it doesn't work localhost, try this one, ctrl and click. Okay, we have our scene here. Do we have any errors? No, we don't have any errors. We are good to go. Of course, it's the default black screen for the render. So we just need to create the things that we need in this project. We don't have any error and we are good to go. So we said that we will create the stars effect with particles. Okay, you may know what particles are. They are like small points, small objects. They have a geometry too and a material or a texture like every other object in the Three.js scene, but with a difference that they don't have a mesh, but they have a point that we will explain and use now so you can understand while doing it better. Where we can start there, yeah, after this, the render. To create the particles, as you have seen in the other tutorials, we create a geometry, we create a material, and then we create a mesh that it's a combination of geometry and material, usually. Okay? In this case, for particles, we will not use the mesh, but you will see. But let's start with the geometry. Okay? So create a variable const particles geometry. Particles geometry. Okay. New instance. We create a new object here, and it will not be a box geometry like we did in the other videos. It will not be a plane. Okay, it will not be a sphere. We will create a simple geometry, the generic class. And we use the buffer geometry because now you use the buffer class for better performance of the geometries in the scene. So not simply because if you I'm mentioning this because maybe you see on YouTube tutorials that they use just geometry, like new 3.geometry, but that is the old, let's say, class. Now Three.js uses buffer geometry. It's memory performance friendly. It has a better performance, so yeah, we use buffer geometry. Buffer geometry. This creates a geometry, okay, for our particles that will be the stars. Geometry for the stars. Okay. New 3 buffer geometry. We are okay here. Let's create a number. How many particles we will want for our stars? The stars are too many, right? They are like hundreds or thousands of stars. So let's create a very big number for these stars. Okay. And let's call it like particles number or particles count. So create a variable const particles count, and let's give it a number like 15,000. Yeah, why not? We have too many stars in the sky. Okay, and this is the number of particles to be created. And here I want to explain something, because for the particles we will use the vertices, okay? And if you know, the vertices has each vertices has 3 values for x, y, and z, because they are like a flat array, and each vertex has 3 values, x, y, z, that are the coordinates of the vertex in the space, in the 3D space. So if it will be like one vertex, one star, okay? So one vertex, one star. But since one vertex has 3 values, like these 3 particles, okay, you can understand that there will not be 15,000 stars, but 5,000. It's like writing here 5,000 times 3. Okay, times 3 because each vertex will have 3 values. Okay, that will be the star. I will explain further here, but I will leave it 15,000. It's the same thing. Do not confuse. Now, for the vertices, we will manipulate the vertices, okay? And to create the vertices, const variable vertices, again new instance from the class float32 array. This is also JavaScript, okay? New float32 array. This is a float32 array, and we'll pass the parameter, the number of particles, that is 15,000, or particles count. We have a variable for that, particles count. Okay, don't get confused, I will explain. Float32 array is an array of 30-bit floats, 32 bits, okay, 32-bit floats. With geometry, we used vector 3, etc., etc. Actually, it was easier with geometry class, but with buffer geometry, we use float32 array. It's more performant, okay? It's faster, etc., and memory friendly. We are not going to talk about that now. But yeah, with geometry, you use like new vector 3 and pass there the vertices, etc. But here with buffer geometry, we will use this float32 array. It's harder to manipulate, but it's better for performance. And this is used to represent an array of vertices. Okay. As we said, the number will be like divided by 3 because we have 3 values, coordinates per each vertex, x, y, and z. 3 values for each vertex. Okay. Coordinates x, y, z. Okay. You have the comments here if you want to go back and understand things. We created the vertices, and these vertices will be in the scene. As we want to create stars, we will give to these vertices random position. Okay, just like random position, and we want to see stars like everywhere. Okay, between the borders of, you know, a box that we will give, a 3D box. Like between these borders, we want to see stars everywhere in a random position in space. How to give a random position to these vertices? There are 15,000 vertices, okay? So, of course, you know the method math.random, and you also know that to access, you know, to manipulate a big array or to manipulate a big number, we loop through it with a for loop. So here, loop through all the vertices and set their random position. Okay. Create a loop, for loop. Okay. For I is less than the number, the total number, and the total number is 15,000, or particle count, the variable that we have here. So particle count I++. Okay. So for each element, for all the vertices, we will use the method math.random that you already know, I think. So vertices I, okay, vertices that we created I for each of this equal math.random. It will be in space like in a random position. math.random, it's okay, a function here, a method, and usually we times 10 times 100 or times, because math.random is a range from 0 to 1. Okay, you will get and it's a float number, decimal number. So to get a bigger range of randomness, you know times 10 or times 100 or times 1000, what you want, times 100, for example. Okay, but since I want to have like a positive and negative number, like left and right, to have things more organized, to have this, let's say, this box where I want these stars. Okay, I will do this. So math.random minus 0.5 times 100. Okay, I will explain now. Minus 0.5 times 100, but we need to put this in parentheses, is basic math times 100. Okay, math.random minus 0.5 times 100. Explaining this. Why 0.5? 0.5 is to get a range from minus 0.5 to 0.5 positive. Okay, so to get a range, like you have the center here, 0, to get a range from minus 0.5 at the left and 0.5 positive at the right. Okay, so you have this range. But since I want a bigger range, times 100, we will get the range from minus 50 to 50 positive. Okay, so we will have this range from minus to positive. So this will be, I will add the comment so you have it for later. Minus 0.5 to get the range from minus 0.5 to 0.5. Okay, then times 100 to get a range from minus 50, right, to 50. Okay, this is why. So we are looping through this particles count, that is 15,000. Okay, and we are setting a random position to each of them. Okay, to all these vertices. Also, we need an attribute for this. Okay, so to this geometry, we need to give an attribute to this geometry here that we didn't use yet, to this particle geometry. And for that particles geometry, okay, we will use the method set attribute, and I will explain. Okay, the first parameter here of this set attribute is the name of the attribute. What is this attribute? This attribute is for the position, so the name position. Okay, and the second parameter is the buffer attribute that I'm going now to search for it on Google so you have it more clear. But let me first write it. So new 3 dot buffer attribute, and here we pass. Let's check on the documentation what we need here. Okay, so 3 buffer attribute. Okay, buffer attribute. This class stores data for an attribute such as vertex positions, what we want, face indices, etc. But we want vertex positions or any custom attributes, what we want. Associated with buffer geometry, we have a buffer geometry for, the particles, which allows for more efficient passing of data to the GPU. Blah, 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 blah. See that page when working with blah, blah, blah. We don't need really this. Then the constructor. As we said before, we mentioned that every class has a constructor, and this constructor is made of array. It's a type array. The item size, that it's an integer, and normalize, that is a boolean. What are these? You are confused what we are talking about. So it was the array, the first parameter, and item size. Okay, and item size means the number of values of the array that should be associated with a particular vertex. For instance, if this attribute is stored in a three-component vector, such as the position, what we mentioned before, if you remember, or go and check the video back again, this attribute is stored in a three-component vector. Okay, so this item size should be 3 because it has 3 values. Okay, for a vector component, right? So the position will have a 3-component value: x, y, z. Okay, so all those vertices will have like this attribute that will be stored of a 3-component vector for x, for y, and for z. Let me explain better with the code. So we are here. This was the first parameter, the buffer attribute, the first parameter of set attribute, sorry, and the buffer attribute, it says here that the first parameter is an array of typed array. Okay, and the second was this item size that we talked about, that we read before. So for a position, it will be a 3-component vector, so the value should be, the item size should be 3. So here, the first was the array, that is the vertices, the number of vertices that we have here. The vertices itself, that is a float 32 array. Okay, so this is the first parameter. And the second, it says here, if this attribute is stored in a 3-component vector, such as a position, in our case, then item size should be 3. All right, so we pass the value 3 here. And yeah, maybe let's add again some comments, so maybe you are confused. Okay, so a beginner might be confused. So 3 values for each vertex. Okay, and they are x, y, and z, right? I will leave here like check the documentation. I always suggest to check the documentation. Check the documentation, okay, for more info about this, right? We have also this attribute for our geometry, particles geometry. So we created the geometry, we created the vertices, float 32 array, we set an attribute to this geometry to accept this three component vector with a value of 3, and we need a material. We always need a geometry and a material, and then a mesh that is a combination of these two, of geometry and the material, okay? To be able to create this 3D object in the scene. For the material, again, a variable const particle material, always camel case, equal new instance, always make it a habit, or always write down, don't copy. If you have the GitHub repository, it will make you a better developer. So 3, and the class is points material. Okay, so we need the points material for this. The particles will be of type points. So points material. Okay, parentheses, and we pass inside an object. When we have a material, we always pass an object. This object will have the properties as any other objects in JavaScript, right? So a key value, color green, name Emilian, etc., etc., etc. What are the properties for this material? Of course, a color, a size. We want the size of this point, which is the particle, okay? We don't need it very big because it's a particle, they will be very, very small. But since I don't want a simple color for these particles, I want a star and I want to add a texture so it looks very beautiful, okay? I will not add the property of color. I will add the property of map. When we want to add a texture, we add the property of map. So map, and map, the value will be the variable for this texture. We didn't create it yet, but I will just pass it for now. Particle texture. Okay, it doesn't exist yet. This is nothing for now because it doesn't exist. I don't have any variable particle texture, but I will create it immediately. I will add the comment texture. Okay, and another property will be the size, as we said. So size, this will be very small, so 0.2. Okay, size of particles. I don't know if you like comments. I like comments. I always leave comments. Another property is size, size, attenuation. Size, am I wrong? Attenuation. Size, let me check Google. I always forget this size, attenuation. Size, Three.js. Nothing. Size attenuation, yes, this one. It's a bool. Okay. Whether the size of the sprite is attenuated by the camera depth. Perspective camera only. We have perspective camera. Default is true. Oh yeah, if since it's the default true, maybe we don't even defines whether okay, this is transparent. Size attenuation. This is what I need to set it to true. But yeah, the default is true. I will explain it better what it means. Better. I mean, not better than documentation, but with my own words. So this is size of the particle will be smaller as it gets farther away from the camera, because here you will not understand much, okay, to be honest. whether the size of the sprite is attenuated by the camera depth. But yeah, the idea is the size of the particle will be smaller as it gets farther away from the camera. So the camera is here in the with a value of 3 to z axis. So we have the scene, we have the particles all over. Some are further away, some are near the camera. Okay, so of course, with the perspective camera, we want that the size of the particle that gets farther away from the camera, okay, we want it to be smaller. And if it's closer to the camera, we want it to be bigger, right? So this is size attenuation. True. We have an error here because I don't have a comma here. Okay. This is, I will add again a comment. So size of the particle will be smaller as it gets farther away. As it gets farther away from the camera. Okay? And if it's closer to the camera, it will be bigger, of course, as in a real world scenario. We don't want, to have the same size, closer or away. It will be bigger, right? Okay. And that's it for the particle material. But as we said, we have this particle checkster, but we didn't create it yet, this variable and this checkster. We will create it now. Let's create it above this checkster. This will be our checkster. For the checkster, again the same thing. Create a variable and instantiate a new class that is the right class for this checkster. And for the checkster, we need to create a new checkster loader. For the checkster, we always need a loader. We create it once and then we can use it. So it's a loader for the checkster. With that loader, we can add the path of the checkster that we have in our folder, or we can add the HTTP URL, etc. So let's create this loader for the checkster. Const checkster loader, checkster loader equal new 3, always from the main object. 3 is what contains everything, and that is checkster loader. Is it here? Checkster loader. Checkster loader. Okay. Parentheses. Now we have this loader. With this loader, we can load the checkster, right? And this is what we can save in a variable to add it here in the map as a property. So we created the name of the variable here, even though it doesn't exist yet. But yeah, this is the name of the variable. So const particle checkster, this one that we passed here as a value. New, new not, because we already have the loader. We don't need new. We are not creating an instance here anymore. We just need the loader, and with that loader we can load, simply load. So equal checkster loader, that load with this method. This will make possible, oh, we don't have an equal, I thought I wrote equal. Here, checkster loader dot load, we will pass the path where we have this checkster. I think I have it because, yeah, in the static folder, okay, I have it, static folder. I have these are the checksters of the planet Saturn. I have the checkster of the star here inside particles. So checksters, particles, star.png. We don't use static here because that's why the static folder is. It recognizes here. So I use here directly slash texters. Okay, so here texters. We don't use static here. So texters, then particles, then star. Texters. It doesn't suggest anything but particles. Then star.png. 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 Textures, particles, star.png. Yes, it's right. Add a texture to the particles. Okay. We passed it here, particle textures to our map property. It should be okay. Yeah, we don't expect to see something. I don't expect to see something. I will check in for errors. We don't see anything because I will explain now. Yeah, but we don't have any errors, so we are good to go. Okay. We have the geometry, we have the material, we created a texture, passed to it. So we need to create the mesh. As always, you have a geometry, you have a material, and then you create a mesh that is a combination of the geometry and the material. With the difference that with particles, we don't use a mesh, okay, but we use the points. So create the variable stars. This will be the stars, the final object, with which is a combination of geometry and material that we pass the texture. So const stars equal new, always the three main object. Dot points we said, not mesh. Usually you use the mesh for a box geometry, a sphere, a plane, and everything. You use the mesh. Okay, the mesh contains the geometry and the material. With particles, you use the points. Like mesh, it is used to render objects in the scene. Points is used to render points in the scene. Okay, so they will render the particles. The difference between points and mesh is that points don't have faces, okay, faces, vertices. So yeah, unlike the mesh. That's why we use points instead of mesh. Too much talking, I know. We said inside, we pass particle geometry. What's the name? Yeah, particle geometry. Particles geometry, and particles materials. Let's be consistent. Let's call it particles. Okay, material. Particles geometry, comma, particles material. Did I use anywhere else this particles particle? No. Okay. Stars. We created, but its value is never it. So to be able to see this, we will add to the scene, as we said previously, that when we create something in our scene, sorry, we add it to the scene. So scene.add, and we pass stars. So I don't know if we forgot something. We have the render scene camera. Okay, no errors and everything is correctly. You see, guys, we have the stars here. Look, it's very nice. Okay, we cannot move anything because we didn't put the controls. We will do it now. But yeah, we created our stars. Of course, we can give it a bigger size. For example, you cannot really see the texture here because I made them very small because yeah, I think the stars look better like this. If you look at the sky, it's more realistic. But to have the idea, for example, what if I put it 2 here just to see? Okay, you see? Beautiful. I like it. Yeah, you see the texture here? Now they have a texture. You can have a better look now. But what do you think? The smaller ones or this? What do you think? I don't know. They look nice like this, right? But if you really look at the sky, or yeah, we are actually in space here because we will add the planet Saturn. So we are in space. We are not looking at the sky from our beloved Earth. So yeah, in the space, yeah, it looks nice like this, but yeah, maybe smaller. You see the particles that are far away, they are smaller. The ones that are near the camera, they look bigger. Okay, that's how we want it. Okay, no errors, everything is correct. Let me try maybe 0.5. Okay, 0.5. I like this one much better. We have some bigger ones, okay, that shines brighter. But yeah, we have these very small ones that are far away. I think this is more realistic, okay? Even though you cannot really see the texture. But I want to make the controls here so we can zoom in depth and we can see near or far, okay? Let's add the controls. And after the controls, we will add our planet. It's a very beautiful model of planet Saturn. My favorite planet, which I have on every social. I have this nickname of the Rings of Saturn. It's like my nickname now. I have it from years, but I don't have any socials anymore. So, but it's the nickname that I used to. We said that we need the controls. For the controls, we use the orbit controls. This is that we already imported since the beginning, but we haven't used it yet. This is very straightforward and very simple to use. Let's find a place first to use this. So yeah, above the particles, or it doesn't really matter. Or camera below the render. Where is the render? Render. Light. Where is the render? Oh, render is in the end. Okay, put it here. Below the lights. Controls. Ground control. David Bowie. This is very simple code. Create a variable, const controls. Okay. As always, new instance not from 3 this time. Okay. Not from 3 because we imported like this. So we don't need anymore to use 3 here, because when you import something with curly brackets, it's like you import specifically that thing and you can use it directly like that. Orbit controls, as I did like it's for the camera, for example, as I did at the beginning, like I import perspective camera here and the curly brackets, and it has from the exact path, so 3 etc camera. Okay, so we don't use a 3 here. So if you have any bugs, or this is, so controls new, as I said, what is the name? Orbit controls. Orbit control. I get lost. Okay. Orbit controls. Okay. This orbit controls has two parameters. One is the camera, okay, and the other is the canvas, and that's it. That's it. Camera and canvas to move around the objects, right? Do we need anything else here? Yeah, usually to these controls you add like a sense of weight. It's like you don't go, you just add a sense of weight to these controls. It makes it more, yeah. And this is with this property. So enable, it's dumping. Let me Google. So controls, enable dumping. Okay, I already searched for it before. Enable dumping, orbit controls. Yeah, this is the usual. Yeah, as we camera render that element, render that DOM element, but it's canvas. As I said, when we don't create the canvas element, we let the renderer generate the canvas, and in that case, it's rendered that DOM element. But we created the canvas element, so it's camera, and the second parameter is canvas. Now, where is this dumping factor? Okay, this one. Enable dumping. Set to true to enable dumping, inertia, which can be used to give a sense of weight, what we said before, to the controls. Yeah, this is. So let's add that. Enable dumping, true. So controls dot enable dumping, set it to true. Okay, that's it. I can add some comments. Set to true is used to give a sense of weight. Okay. Always comments. So you don't say that, oh, Emilian didn't explain it very well. We have the controls, but yeah, we cannot use it. Okay, yeah, we can use it. We go a little bit. Oh, the stars. Yeah, we can use it. Nice. This is our stars. You see, guys, we can zoom in and zoom out. The stars now are far away, now are the texture looks nice. Huh? You can search for Google if you want other textures, I don't know. Or you can add some color to it. You can change the random position bigger. Yeah, your choice. What else? We have the controls. What we miss? Yeah, apart from the planet Saturn. What we miss? Oh yeah, we need some animation, right? Because yeah, we need some animation for the stars. We need just a bit of movement to give that idea of floating in space, that everything moves. Okay, we'll make it very very slow, so we don't make it fake. Okay. Here in the animate function, first controls.update. This is to update the controls on every frame. Okay, looks nice. Yeah, it gives the idea of a space floating into space. Yeah, I like it. I'm happy with it. I'm happy with it. Yeah, and some animation about the stars. For that, we need to rotate, just slowly, but rotate it in the x or y axis. X axis. But it depends how the object, because sometimes you think it's x axis but it's y axis. We will check. Rotate a bit the stars. It's very straightforward and easy to do. Pause the video if you want to try it yourself. And always I'm referring to the beginner. So pause the video and try it yourself to rotate this guy. And keep in mind that we are inside the animate function, so it will render on the next frame. So on each frame it will render. So if you move an object, or in this case the stars, okay, we will see on each frame, okay. So yeah, the value will be changed on each frame. I think you guessed it, how to do it. First, stars, from stars variable. Stars is the variable that we gave, right? Where is it? Stars, where are you? Okay, stars. Yeah, stars is the combination of the geometry and the material. That is the 3 points. It's stars. So stars dot rotation x-axis. Try it, x-axis. Here is plus equal. Plus equal. Let's give it a very, very small value. 0.001. Okay. This is the same as doing stars.rotation.x plus equal stars.rotation.x plus 0.001. Okay, it's JavaScript. It's nothing to do with Three.js. So it's the same as plus equal is the same as writing stars.rotation.x equal stars dot rotation dot x plus 0.01. So what we have plus 0.001. Then the next frame, what we have is plus 0.01, and so on. So we move it in a loop. We rotate it, not move it. We rotate it in a loop with this value of 0.001. Okay, but yeah, it's cleaner like this. Okay, let's check if it works. Yes, it works. And very beautiful. It's only that it's moving, like up and down in this axis. Okay, so it's not, as I said before, you think this is y-axis, but it's x-axis. Okay, let's try it y, because I want it, this way. Y, and it should be okay. Okay, very nice. Maybe it's too fast. Yeah, it's too fast. It's for an animation. If you want an animation on your website, it looks good like this. But to make it more realistic, it should be slower than this, right? But yeah, if you want it for a website, looks good with this velocity. But I want it, if I put another zero here, 0.0001. Oh, very slowly, and I think it's nice. Yes, this is the effect that I want. Yes. Okay, very slowly, but nice. I will leave it like this with this value. You can do what you want. I will leave it like this. And this is done. So we created, guys, uh, our stars with particles. So pretty much this is how to work with particles. Then again, if you want, for example, create a rain effect, okay, you want the rain effect. You want to create the rain in your scene. Again, I think it's the same thing. Like I can say it's exactly the same thing that we did. And maybe, yeah, maybe not this size, make it everything smaller. Where is the size here? Particles, particles. Yeah, the size 0.5. Let's try since we are here. 0.1. Okay, let's see. Very small. Okay, let's make the rotation here. Rotation not horizontally, but yeah, we want the rain to drop down. So X, make it faster. Let's see what happens. Oh, okay, I will start the server again. npm run that. Every time you want to run this server with webpack that we have here, you have it ready. You just need the first time that you take this folder from my GitHub, run npm install. It will install all the dependencies, the external libraries, etc. After installing the node modules that has also 3 module inside, you just need to run npm run dev. Okay, it will start the server. Simple as that. Let's wait a few seconds. I want to see if the effect of raining looks as I was expecting. Ooh, okay. Okay, no, not this one. I should manipulate it better. Yeah, okay. It's we don't do this rotation. We will change position maybe, but maybe we need the loop. But yeah, the idea is this. Position Y. It goes up. Or if minus. Okay, minus. For example, for snowing, you get on Google a texture of snow. You have a lot of textures on Google. Just search, okay? Search for texture of snowing, or you can add a simple color of white. But yeah, it's better with you know the snowflakes. And yeah, you see this just dropping down. We can change a bit the position, make it and faster, or for the snowing 0.1. Yeah, okay, you see this looks like raindrops apart from the ones that are Okay, they finished. Apart from the one that are far, but yeah, the idea is this. You see, they drop. Yeah, this is the idea. You have it. Let's turn back to our stars. You can imagine the texture of snowflakes here, or we had rotation. Rotation y 0.0001, I think. Stars rotation, and the size was 0.5, if I remember. Okay, yes, this is, yeah, the parameters I want. It looks good like this. I will leave it like this. I like it. The last thing, and we are done with our project, is to add the planet Saturn, okay, to make our project look nice. So we are done with the particles. Let's add this. I will do it very quick and simple, in a simple way, and you will see. And I will not go into it in detail for many kind of options or purposes, but I will just add a model toolsyn in this case. Okay, so I will not go in detail about how to do these things in different projects, etc. That have you should go deeper into things. Maybe in another. I do that actually in my other tutorial about create interactive portfolio. I'm working on my portfolio website. It is also based in space. If you didn't see, check my channel. It's I import some models and put it in my portfolio website. And yeah, there I do some more advanced things also with physics, etc. I add I tweak parameters there with a UI configurator like you have in your Adobe Photoshop or Illustrator or Blender, the options to tweak the parameters. Yeah, you can do this with Three.js. You can create a UI debugger here, like a configurator. You move the slide and you move the position or you change the color dynamically. For example, if you have a designer in your team, you cannot do things. Imagine if you need to change like each particle, specific, or you want to position something. Imagine a big scene with many objects. It's very difficult. You can spend hours and hours. You create a UI debugger configurator, and you can tweak the parameters in real time, so you can see while you change the parameters there in your UI configurator. And I explained this in my other tutorial that is in my channel. Create interactive website portfolio. Check it. And if you are curious or you need something like that. Okay, let's add this model of our planet. Okay, we are here, good to go. For that, we need this GLTF loader that I imported since the beginning. Okay, let's go here down. Yeah, here above the render. Import the planet Saturn. Okay, so you will see how simple it is to import a model, and you will, I'm sure you will do it yourself with your website portfolios or your projects. Okay, importing, you can find any kind of free 3D model on, on Google, and you can add your models, everything, and make your website look cooler. Okay, and you will see how easy it is. For that, first of all, we create a variable for a loader, and we call it gltf loader. So const gltf loader variable. Okay, again, new instance from this gltf loader that we imported. Okay, so we don't use 3 because you see we import it like this. So we can use gltf loader here without 3. Okay, we are in gltf loader parentheses. That's it. We have the loader. Okay. Here, make some space. Here, we use this loader. As with Checkster loader, like the same thing, we use gltf loader.load as we used Checkster loader.load. gltf loader.load method. Okay. Inside, we put the path of the module that we have. Okay, like we did with the Checkster. And the model, isn't it here? Oh no, it's not here. Okay, I have it, and I think I didn't delete it. Well, I hope so, because it was a very beautiful model. I will credit the creator. Oh yeah, I think it's this one. Yeah, this one. I should import everything, if not, it will not work. But I already have the checksters. Yeah, I didn't delete the checkster. I only delete the model. I need to import the scene.bin. I have the checksters, right? Enceladus, Mimas, Saturn, Saturn 1, Saturn 2, Saturn 1, Saturn 2. Yes, these are okay. The bin. Okay, do I need anything else? You see, this is the model. It's like in JSON format. It has every kind of properties of that model has. You can also modify it here if you are, advanced guy. But okay, it's pretty huge. Let's try. I don't need anything else, I think. No, I don't need anything else. Okay, this is the license. I will credit the creator in my description. No, I don't need anything else. But I leave this window here open if I do. So the path is gltl load. The path is we don't put static, so directly scene.gltf. Okay. So the path is slash. That is like it recognizes the static. So scene.gltf. Okay. we loaded that one, and here the loader, the load method, more exactly, because the loader is this and this is the load method. uh, we need to pass a second parameter. The first parameter is the path of the module. The second parameter is a function, so arrow function. Okay, and this function will make possible to add the module to the scene. We load it, but now we need to add it to the scene. And to add it to the scene, it will depend on the model, because it depends. Many models, they have different meshes, they have different children's. If you want to save also the animation, the lights, the shadows, different meshes. For example, the planet Saturn may have many children that are 3D objects, and these children has meshes, animations, lights, etc. So to add all this, you may have to manipulate with a for loop, or it depends. It really depends. When you are lucky, you can simply add scene.add gltf.scene. I will explain it here more. Let me add a console log. Console log success. I do more advanced tutorial on this in my other video about creating my website portfolio. If you want to go deeper. Yeah, another console log just to check the model. I want to show you how the model is. Okay, name for it, and gltf. gltf is this one that we will put as a parameter in the function. gltf. You can call it as you wish, but yeah, this will be, the gltf model. This second parameter that is a function will accept this gltf model, and I will console log it here. Okay, so you can see. Let's open console log. You see here I console logged it. It's correctly. I didn't do any error. I usually make mistakes, but not this time. So let's open this object. It's an object. And you see animations, asset, cameras, parser, scene, scenes, user data, etc. And our model is inside this scene. Let's open scene. You see inside scene there are other animations, cast shadows, children, matrix, position, quaternion, etc., etc. Rotation. It has its values, the default that how they created it in Blender or 3D Max or whatever. Okay, it has a lot of data. Okay, usually, as I said, you can access this by gltf, which is the model we passed it as a parameter. So gltf is the model, this one that we already loaded. Okay, so gltf dot scene. Okay, usually it's gltf dot scene. So simple as that. Const Saturn equal gltf dot scene. Okay, usually is this simple. Okay, but as I said, it depends, because you may have many children that have many children that has many children, or you want to grab only the first children because they're You may have many objects. You only want the first, so you want to go gltf, which is this main object. Okay, we are here as I okay, Saturn here is this gltf, and gltf dot scene dot children and array 0, for example. Okay, so gltf dot scene dot children array, it's an array, right? It's an array. gltf dot scene dot children dot the first the method, it has only one array, you see, array 1, and it's the index 0. So an array has indexes. This is index 0. So children dot 0. Usually you may grab the module here, but sometimes, it depends. If it has many children, you may do a loop like for of loop, for of loop. Okay, so const child of gltf, which is our module, and scene.add child. So you add every child. Okay, you iterate to those children and you add every child. Sometimes when you need to also get the animations, you need to do a reverse. Yeah, it depends, but as I said in my other tutorial, I talk about it more because I am importing like more than one module. I'm importing several modules. They are different, so you can take a look at it if you want to go in depth. Okay, for now, let's try the most simple way, which is gltf.scene, and let's see if it works. Saturn gltf.scene, and let's add it to the scene. So scene.add Saturn. Okay, so we add the Saturn here. That is gltf.scene. I think it should work, but let's try. No errors, but yes, we see it, even though it's very, very big. Okay, now we see also the textures in black. It doesn't look good, but yeah, you see the model is there, but it's very, very, very big, as I can see. Oh, it's pretty big. Oh, I cannot even see it because it's so big. The camera cannot, yeah, it's very big. So let's change the scale of this object. Make it look smaller, okay? For that, you can access the position and the rotation with object.position, object.rotation, and in this case, Saturn.position, Saturn.rotation. First of all, let's put it in the middle of the scene. So Saturn.position.set to set all the three positions, or individually .x, .y, etc. So 0, 0, 0, x, y, z. So it's in the center of the scene. Now let's change the scale because it was very big. Saturn.scale. Okay, it's for the size. Saturn.scale again set to set all the three, x, y, and z. Scale.set. I don't know. I have no idea what number to put. So since by default it should be 1 and it's very, very big, so we should make it smaller than 1. So 0 0.1, 0 0.1, and 0 0.1. Okay, yeah, I think it should work because it's a very small scale, Let's see. Nope. It's still very big. Okay. Let's put another 0. 0. If you want to do this, if you don't know, just click where you want, to change, for example, in 3 positions here. Click here at the first, press Alt, and then with Alt pressed, click here or wherever you want to, multiple change. So 0 0.1, 0, 0, 1, 0. Okay, let's check again. It's still very big. Okay. Add another 0. Alt here and here. 0. Let's see if it's still very big. Oh, 0, 0, 0, 1. Okay, better. Yes. But why it has like it's very. But yeah, guys, you see, and it's very beautiful. Take a look. These are particles, by the way. The rings, they are particles. Okay. If we are going to do it from scratch, this model, yeah. But we are not going to do it from scratch, that one. I have it ready from a great 3D modeler, 3D artist. I don't know if this is right. 0. Yes, I thought why this has like this shape of, but I see. This is 0.001, 0.0, 0.001. It's very, 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 very small. Maybe. Why so big? This model is okay. Still very big. I don't want it so big, but that's the last change, I hope. This is why you need a configurator here, a UI debugger. If I have a UI debugger, I can tweak these parameters. Okay, I create this UI configurator and I can tweak parameters as I wish and in real time. Okay, that is why it's so useful. Okay, that is why it's so useful. I don't like these textures that all these stars, but yeah, we can fix it. It looks good though. Okay, in this position, this rotation, it has lights. You see, it's its own light, but it looks good. Yeah, it looks good. We can move around, or we have the orbit controls. Yeah, guys, I think yeah, it looks good. What do you think? It's like that website of NASA, right? Huh? Pretty much. Okay, I think it's. I don't know how long was this tutorial, but maybe 2 hours. I don't know. I have no idea. But yeah, this was the tutorial on particles and on adding a 3D model. I hope you learned something from this and enjoyed. I will make other tutorials on Three.js, on Unity engine about 3D programming in general. So yeah, if you are interested and if you like this tutorial, please consider subscribing. I don't know what I need to improve. Actually, I'm not an instructor. I'm not an expert. I'm not an educator, really. So I'm just experimenting. I have no idea how it looks, how you for someone that is learning. I have no idea actually if I explain very bad, or I don't know, or if I am boring. Maybe my tone of voice is boring, but yeah, this is my way to speak. I see some tutorials on YouTube. They are very enthusiastic, like with very hyperbolic tone. Like they are creating the next big thing. I cannot do it, to be honest. I cannot speak that way. I don't know. I see some tutorials on React, some guys there that with a lot of I cannot do it. I just make this you know small projects, and I hope that someone like them. We also have the moon here. Look, maybe yeah, it's Europe. Very nice. Okay, I like this final project. What do you think? I like it. See you in the next video. Bye.